Hello. Today we're going to do some problems. It's the first problem for computing torque. Now we're going to do. Imagine a bar that's maybe 20 centimeter long. One end of the bar is there's a hole and there's a peg that's supporting the bar, and it can rotate about this peg. Okay, we're not going to study the rotation yet, just the torque, how much torque is a particular force applies. And maybe there is something tied here, and a force 10 Newton is applied in that direction. Okay, and that direction is 30 degrees in that way. There are other forces. There's a force of gravity and other things. We're not looking at that right now. We just want to figure out the torque by this force about this point. Let's call that point O. Okay. So, first question is how to find the torque. We're going to use lever arm method. There are other methods of kind of setting this problem up, but I think the lever arm method is very visual. So lever arm method says go to the force. So the steps is, first step is extend the line of the force. So line of force. So here is the line of force, is go to where the force is applying and draw this line. It's kind of like a vector diagram without the arrow. So I draw this line, and the second step is you should try to draw as I'm drawing it. Okay, it's very important for you to yourself, not just watch this video, just draw as I draw and follow along. So the next thing I'm going to do is go to O, the pivot. This is also called pivot point about which I'm going to look for rotation, and I want to know influence of this force in the rotation process. Okay, so we draw a 90 degree onto that line. So go, so this is draw another line from pivot to the line of force. Okay, but this line that I could draw a whole bunch of different lines, right? So which line I should draw that strikes the line of force at 90 degrees. So I draw that has 90 degrees. So I don't draw these guys. I mean, you could draw a line from here to there, but I'm not drawing that line. I'm drawing this line, and this is what is called lever arm. This one is not lever arm. Okay, I want to figure out that level. I want to figure out that distance. That's the effective distance around which this force is acting. So this third is find lever arm, which I denote by, just to remind myself this is 90 degrees, I denote with a perp here. So this is our perp. Usually you're going to find a triangle. This is sometimes difficult for students when learning first time. To look for a triangle, to find this, at this process you got to look for a triangles. And here I find this triangle. From here to here I know 20 centimeters, and I need to find this, and this is the 90 degree in that triangle. So in that triangle, if I could figure out this angle or this angle, I'll be done, right? Because I know the hypotenuse. So, but this 30 degree makes it, this guy is 30 degrees. So in that triangle that I'm trying to solve, I want to solve this side Okay, and I know this is 30 degrees and this is 20 centimeter. So the R perp at this point is going to be, this is the R perp, is going to be 20 centimeters sine 30 degrees. 20 centimeter sine 30 degrees. This is going to be lever arm for this force. So once I've got that, sine 30 degrees is half. So that becomes 20 centimeter times half. That becomes 10 centimeter. Make sense? Okay. Now the magnitude of torque is just the magnitude of the force times the lever arm. Is that the product is equal to the magnitude of the force, which is 10 Newton, and the lever arm. So if I do 10 Newton times 10 centimeter, okay, so I got 100 Newton centimeter. Well, you may want to convert this mixture of units, right? So you want to convert this into a meter, and that will be 100 Newton centimeter times 1 meter over 100 centimeter. So centimeter cancels out. Let's look at a Newton meter, and this 100 cancels this. So this is actually 1 Newton meter. Okay, so we are not done yet. At this point, the students can stop and say, okay, I'm done. I found the torque. But from previous studies, you know the torque is, this is just a magnitude. If this force was acting in that direction, it will have exactly same value, right? If it was acting that direction. So these two forces will have the same torque, but they don't have the same influence on rotation, right? So this force is trying to rotate that way. This force would have rotated the exactly opposite. So we give direction by sense of rotation. This is, I'm looking at it from the perspective of my view from the front. It looks counterclockwise. Okay, so this solves the problem of finding a torque of this force around this axis, which is acting on this. So if I want to summarize what did I find in a complete way. So we found answer to this question: torque of 10 Newton force acting at point P, 30 degrees counterclockwise from pivot O. So this was the direction, 30 degrees at distance 20 centimeter from O. Okay. About axis through O. And if you want to become more complete, you'll say axis through this perpendicular to the drawing. So I'm going to stop here. You should have more practice doing this.